Hello guys, my name is Diego Pacheco and this will be a video about GraphQL. So this video we're gonna code in Java, in Go, and in Rust. So GraphQL is an interesting approach for data aggregation. So today we're gonna see a live demo I made here and some coding in regards of the server. The server will be built in Java. And the client, we're gonna have two clients, one client in Rust, another client in Go. But pretty much it could be the other way around, like the server could be in Rust or Go, and GraphQL supports so many languages. So let's get started. So let's start with the server. So this server is a Spring Boot application. It's a Spring Boot 2 application. As you can see here, we have the starter web, starter test, all the Spring Boot things. In regards of GraphQL, there is this GraphQL Spring Boot starter. There is the Spring Boot Starter Web MVC, there's GraphQL Java Tools, and GraphQL Java. That's our dependencies. So the application, let's start with the schema. So in GraphQL we have a schema. So we have a file called schema.graphql, and here there is three structures. There is a query, there is a book, and there is an author. So the book, it has an ID, a name, a page count, and an author has ID, first name and last name. The query is a query, and this query is called book by ID, where you pass an ID, the type is ID, and you receive a book. Now let's take a look on the application. So there's this application file where we pretty much boot up a standard Spring Boot 2 application, where there's a Spring Boot application, enable auto configuration, and components come, and we just run this class, no really big deal. Then there is the providers and data fetchers. So the data fetchers basically simulating some data in memory. So there's an array list of is a list of maps. So a list of maps, and in each map you have a book, and a book has ID, name, page count, and author ID. So there's three books: book 1, book 2, and book 3. Book 1 is Harry Potter, book 2 is Moby Dick, book 3 is Interview with the Vampire. And then there is authors. So Joanne Rowling, Herman Melville, and Anne Rice. So again, a list of maps with authors. We could be reading this from the database, but this video will be longer, the code will be longer, so for now this is fine. You can replace this code with any database code, to Cassandra, Mongo, MySQL, whatever you want to do. Then what's important here is the data fetchers, right? So there's two data fetchers. So there's a data fetchers get book by ID and get author. So the author is basically we get the source, and then based on the author ID we get the book, and then from the authors we stream that, we filter, because we just again we don't want all the authors, right? We're only the ones that has the author ID we want, get the first or no. For the book is we look for the ID, right? Then we stream this collection here, the list of three books, and we filter the book where the book ID equals the book ID you pass, and then we return first or else, whatever, right? So this code pretty much could be, like I said, calling database or getting the data from an API or whatever we really want. So this is the features. Now we need to look at the provider. So the GraphQL provider is a component. We have a great GraphQL data fetcher, which is the class that we just saw it, and a GraphQL. Then the pulse construct annotation means this code will run after this Spring Bean is initialized. Then we're gonna get our schema, and with that we can build our schema and we can build our GraphQL engine. So we're gonna have a GraphQL. Then for the build schema, we need to create a type registry, and that's doing by parsing the schema SDL. Then we need to have a runtime wiring. Then we need a schema generator, and the schema generator we make the schema executable, passing the registry and the wiring. The wiring, we pretty much say what you can do. You can do a query, and you can do a book, for instance, and the query, is by ID, and here's the fetcher for that query. The book is by author, and here is the fetcher for that case. So we are connecting all the dots here. And finally, return our being of GraphQL. Before I run this application, let's take a look on the client code, right? So here I have the code in Go. I'm gonna open this with VS Code. So we build a client. This is machine box GraphQL. This URL is my Java GraphQL server. Then we're doing a query, which is a GraphQL new request. And this query we are expecting to receive a key ID. And then we're gonna call book ID, passing the ID. And we want the name, the page count, and for an author, we want the ID, first name, last name. Remember, in GraphQL, you can ask for everyone. Like, for instance, we could omit this ID, or let's say we don't want the last name, we could remove the last name from here. Then we need to do the binding. So here I'm saying for the key, I actually want the book number 3. Setting some headers. We need to create a context, and then the result will be a map. So we create a map with generic interface in Go, and then we do client.run, passing the context, the request, and a pointer to the response data. So Go by reference will put the response data here. And if by any means there's an error, we're gonna log an error and abort. Otherwise, this code here, I'm just using JSON to pretty print the result. And that's the code for Go. Now let's take a look at the client in Rust, and then we can run all these applications. So here in my cargo.toml, in my dependencies, I have the GraphQL client, also request, surd, GraphQL and Tokyo. The schema is also duplicated here, and we also have the query here. So in my main.rust, we need to use surd with GraphQL query, and then we're gonna pass some GraphQL definitions. And we need to say where is our schema, where is our query, and I want the response drivers in debug mode. And this will be binded to a book query structure. Then I have a method to perform a query, which is async. That's why we are using Tokyo here. And then I'm passing some variables. The variables needs to be the type book query variables. And this will return a dynamic result with a boxed dynamic error, either result or error. Then we need to build a body. So we use the book query structure, build a query. We build our client using request, putting some user agent saying this is GraphQL Rust. Then once we have the client, we can do a post. This is the Java URL for the GraphQL, passing the body, and finally we got the response and repeated response here. On the main, I'm just passing the variables. So I'm doing book query variables, passing the book ID, and the book ID is 1. And finally I do my query and I print my results. So now it's time for us to run all these things. So let me see if I can run in Java first. This should do in the console, because I configure my idea to be on the same window, so I don't want mess it up, the window running in the application. So yeah, I have the GraphQL server running here. We can run the code in Go just by saying go run in my main.go, and we can take a look at it. Works. We can see we are able to retrieve book 3, and also I can run my Rust. I can do cargo run here, and you can see I'm able to get the book. Remember, in Go I ask book 3, in Rust I ask book 1, and that just worked here. As you can see, I get the Harry Potter book, and I see also the authors here, and that's it. So that's it, guys. So we have GraphQL up and running with Java 15 as server, clients in Rust using Tokyo, and in Go using Machinebox GraphQL. So I hope you guys like it. See you next time. Cheers.